Welcome. In this video, I'm going to demonstrate how to find the projection of one vector onto another. In this case, we're going to find the projection of vector v onto u. So both cases for a and b, we have v onto u. But before we move forward, let's just look at visually what we're doing. So I'm going to go ahead and sketch vector u here, vector v here, and I'm going to drop down this perpendicular line, and this blue vector here, that's the projection of v onto u. And then we can use right triangle trigonometry. Let's go ahead and label that theta to figure out what this projection is. So the cosine of theta is equal to the length of this adjacent leg, which is the magnitude of the projection of v onto u, divided by the length of the hypotenuse, which in this case is the magnitude of v. Okay, so I can write the magnitude of the projection of v onto u as equal to the magnitude of v times cosine theta. Well, we also know that cosine of theta is equal to the dot product of these vectors divided by the product of the magnitude of each. Okay, so that tells me that the projection of v onto u is equal to the magnitude of v multiplied by u dot v divided by, again, the product of these magnitudes. Now, we don't want the magnitude of this. We want a vector, so let's go ahead and multiply by a unit vector in the direction of u. So in this direction, to get a unit vector, we just need to divide by the magnitude of u. So I have the magnitude of v, and I'm going to clean this up. Just wait a second, please. Times u dot v divided by the magnitude of u times the magnitude of v times u over the magnitude of u. All right, so what do we end up with? You have u dot v over the magnitude of u, and then you want to multiply that to this unit vector. So let's go ahead and find, first of all, the dot product, u dot v, that's equal to 1 times 2 plus 0 times 1 plus negative 2 times negative 1. This is 2 plus 2, so that's 4. The magnitude of u is equal to the square root of 1 plus 4, which is root 5. Okay, so now let's go ahead and write this out. So the projection of v onto u is equal to this dot product 4 over the square root of 5 times our vector 1, 0, negative 2 divided by its magnitude here. So this becomes 4 over 5 times 1, 0, negative 2. So the projection of v onto u is equal to 4 over 5, comma 0, comma negative 8 over 5. Now for part B, what we're really doing is the only difference is we've swapped the values of u and v. So you could really say determine the projection, and keep this the same, of u onto v. And I kind of prefer doing it this way because it forces you to not just stick to a formula and really think about what you're doing. So in this case, I want to start again with the dot product of u and v, which is going to be the same as in part A. The vectors are the same. So again, u dot v or v dot u is equal to 4. And now we want to find the projection of u onto v rather than v onto u. So we need the magnitude of v this time. So the magnitude of v is equal to the square root of 4 plus 1 plus 1, which is root 6. And again, I purposely switched these back to their original names of these vectors. All right, so now the projection of u onto v, That's equal to 4 over the square root of 6 times vector v in this case, not vector u. So vector v of 2, 1, negative 1 divided by its magnitude of root 6. So we end up with 4 over 6 times 2, negative 1, positive 1, 1, negative 1. There we are. So that's 2/3 here. So 2/3 times 2 is 4/3. 2/3 and then negative 2/3. And that's the projection of u onto v. I hope you found this video helpful.